So in this case, we have another typical exam revision that we are going to look into as we are preparing for the exams that are ahead of time. So this is paper two, as we requested that we are going to also need paper two to cater for the one that we had. So unfortunately, guys, we are not actually having the November 2024 exam. It is not available. Like I actually tried to look for that question paper, the November 2024 one. So I couldn't manage to get one. So what we're going to do is to use the November 2023 exam. So guys, what we need is to understand how do they ask the questions. And basically they do repeat the way they ask these questions. So understand that, revise as many questions as you can, all right, according to your syllabus. All right, so that is it, guys, for our GEC exam paper 2. It was a 75 out of 75%, that is 75 marks there. And in terms of the duration, 120 minutes excluding the 15 minutes reading time. And there we are given all right, guys, everything there it is about showing the calculations. Number 5, do your calculations before choosing the correct answer in what? In section A. Then in section B, all calculations must be shown, all of them. All right, that is the necessary part. You are supposed to show all the calculations. Okay, so without wasting your time, guys, this is our section A, where we are given the multiple choice questions, and we are given number 1, which is our first question. Lines AB and CD are straight lines. A, B, and CD. So we are given this line AB and the line CD. They are straight lines. So why is P 88 degrees? Why is that this angle P is 88? So in actual sense, or in most cases, you are used to a condition where they are going to ask you, like, what is angle P? Then, okay, angle P is 88. That reason that you are giving to say P is 88 is the one that they want you to write. Why is that so? We remember our vertically opposite angles from the straight lines. These two angles that are vertically opposite to each other, they are equal. So that is what we are going to look for on our answers: vertically opposite angles, which is the one that we are having on C. It is vertically opposite to what? To 88 degrees, this one. So that is the condition that you are going to have on that part. It is the reason. Already you are given the answer there. So what is the reason? Why is it that they are equal? Number 2, given that AB is perpendicular. So that is what? Perpendicular there at 90 degrees. So AB is perpendicular to CD, meaning to say where AB, this line AB, and CD meet, where they meet at what? 90 degrees. So this is 90 degrees. This is also 90 degrees on that other side. So the question here was, if we are to consider our question, okay, let's see the part of our question. What is it that we are supposed to have? Why is that? Okay, what is the size of what? A1. They want the size. What is the size of the angle? A1. Okay, so A1 on our diagram, if we are to consider on our diagram here, this is our A1, which is at what? At 90 degrees. So remember, right angle, perpendicular, it is at 90 degrees. The same as our A2 at what? At 90 degrees as well. So this is the condition. So the answer there, which is the best, is 90, which is on what? On D. So this is how these questions sometimes they are given as. All you just need is to understand the basics of the question to say how the question is given, how is it given, then you figure out from the understanding of our geometry. All right? Perpendicular at 90 degrees. So that is what we have there. Okay, so let us move on to question 3, which is where, okay, there we are given lines that are parallel. As we can see, this is AB, that is A, B, C, D, this is E, this is F. And there we are given this condition, this one, parallel. And that's angle A, there is A, there is B here. All right. So that is the condition. AB is parallel to CD. These two lines, they are parallel to each other. So the question was, what is the relationship between angles marked A and B? The relationship. So remember, if two lines are parallel, then we have got the transversal line, which is the line EF. The angle here and this angle, they are equal. From where? Corresponding angles. Remember where we obtain an F, the one that is inside and the one that is outside. Those ones forming an F, they are referred to as what? Corresponding what? Angles. So that is the relationship, guys. In terms of these angles, they are equal. A is equal to B. Remember the properties of corresponding angles. So that is it. Corresponding, which is on what? On C. So 3 is C. All right. So the first one is complementary. Complementary. These are two angles which add up to 180. And complementary, that is 90 degrees. Sorry for that. So if we are given this one and this one, they are co-interior angles which add up to 180. So adding to 180 is what? Supplementary. So guys, these terms, there'll be a lot of terms, but you just need to know them, guys. There's no way. So complementary, two angles, all right? Two angles which add up to 90 degrees, all right? So supplementary, two angles which add up to 118. All right, so this is co-interior. Then alternate angles. Remember, that's where we are forming a Z, alternate angles. So that one is totally out. All right, so that is the condition. Remember your properties. So guys, we just need to understand the basics of your properties from your geometry. That can be very helpful. Let us consider another question, which is on number 5. So it was not clear enough, but that is the angles that we are given. This is 2x. This is 2x and this is 3x. So actually, guys, you can download the question paper or if you check the description of the video so that you can be able to see these questions properly. All right, so they were given, what is the size of EOB, the angle EOB? Okay, where is it? Where is this one? This is the E, this is the O, and this is the B. So this is it, E to O to what? To B, like this. So that is the angle that we need from E to O to B. So the angle created there is what? Is the 3x, this one. This is the angle created. It is 3x. That's our angle, EOB. We have x there. But if we are to consider our answers, they are not given in terms of x. So what are we going to do? We must find the value of x. So to find the value of x, there are so many ways, guys, that we can use. We can consider angles on a straight line. AOB is a straight line. From A to O to B, we have got what? A straight line. So angles on a straight line, they add up to 180 degrees. So you can use that. You add 3x plus 2x plus the 90 degrees, the right angle that you're given there, which is 90 degrees. You equate to 108 angles, what? On a straight line. angles on a straight line. Or you can simply use the 90 degrees that is remaining here. Remember, guys, this is perpendicular. So this is 90, this is also 90. So it follows that from C to O to B, it is what? 90 degrees. COB, that angle is what? 90 degrees. So thus, if I'm going to add the 2x here and the 3x, we are supposed to obtain what? 90 degrees. So we can use that 2x plus 3x is equal to what? 90 degrees. That's another way that you can actually use. So there you are dealing with what? Two angles adding up to 90 degrees, which are complementary angles. So you can use this condition, you solve for what? For x. You can use this condition, you solve for x. It's still one and the same. You're going to obtain the same thing. So let us just use this one. Guys, you can use this. It's up to you. 2 plus 3, that is 5x. Those are like terms, which is equal to 1. That is 90 degrees. Sorry, this is 90 degrees. So to find x, simply divide by what? By 5. So our x in that case was going to be 18. That is 18 degrees. We have the value of x, which we are going to substitute here in place of x to find the angle that we are being asked, E or B, which is given as what? As 3x. So substitute the value of x that you have obtained there. So that's 3 times our x, which is what? 18 degrees. So multiplying this was going to give us 54 degrees. Okay, so the best answer, 54 is what is A. So don't be tempted there on C. C is not the correct answer. That is the value of x. The question needs us to find the angle E or B. So it is given as what? As 3x. So you must substitute the value of x. It is different from a question where you are being asked to calculate or to find the value of x. In that case, you just end at this point. By solving, you are done. But in our case, they need the exact value of the angle. So it can be also, they can ask you to find C or E, from C to O to E. If it was like that, let's say they want you to calculate that C or E. It is given as 2x. That is what we have. So as a numerical value, you must substitute the value of x that you are given, which is what? Which is 18. And that was going to give us 36 degrees. So we have got a 36 degrees and a 54 degrees for what? For EOB, which if we are to add these two, we must obtain what? 90 degrees as mentioned before. Or if we are to add these three angles together, these three, all of them, we must obtain what? 180 degrees for angles on a straight line. So it can be another way. For another question, they can ask you maybe COE. You must know how to attempt that. You find x first, then you substitute to whatever that you're being asked on that question. All right, number 6. Given the lines that are parallel from B to E, this condition, and the C to D, which is this one, they are parallel. And we have got an angle of 68 degrees here. This is 46 degrees, and this is F. All right, this one is F. So the question here was, what is the value of what? Of F. What is the value of angle F? So to find F, there are so many ways. As we have got the lines that are parallel, someone can consider this as what? Alternate angles where we form a Z. So the angle that is F is the same as the angle that is at E, where we form a Z, remember. So this angle E and the angle F will be what? Will be equal. So someone can consider that to say angle F is equal to angle E. Alternate what? alternate angles. But we do not have angle E. We can calculate this angle E from angles in a triangle, which add up to 180 degrees. So that is our angle E. From 180 degrees, we are going to subtract the two angles that are inside the triangle, which is the 68 and the 46 degrees. Those are the two angles that we are given. So from 108, as we consider what? Angles in a triangle. That is from or in a triangle what? In triangle E, BC or BCE, no matter the way that you want to call it, guys, okay? So that was going to give us the value of angle E, 180 minus these two angles, 68 plus 46. So that is 66, all right? So we have got 66 degrees here, which is the same as the angle F. Remember, we said angle E is the same as what? Angle F from alternate angles. Alternate angles. So there we have got our 66 on what? On B. There are so many ways. We could have considered this from alternate, from the perspective that if we are to consider co-interior angles here, they can work. It can actually work. All right. So we can actually consider that. Another way. Let's consider this. We have got co-interior angles. As we can see, we are forming this condition of C angles, or where we form a U like that, co-interior angles. They add up to 180 degrees. So if we are to consider in this case the angle that is of 68 degrees, the 46, and this angle F, all right, 68 plus the 46 degrees plus the angle F, supposed to give us what? 180 degrees. Those are co-interior angles. So from there, you can calculate this angle F. All right, so take this to the right-hand side. That was going to be 180 minus 68. We take the 46, gonna be a minus again. So that is our angle F. All right, so let's consider this. 180 minus what? Minus 68 minus 46. So that was going to give us 66 degrees, which is the same as what we obtained previously. So there are actually so many ways that we can consider there, as long you are working with the exact properties from your geometry, from your parallel lines, from the triangles. All that must be taken into consideration. Number 7, we have got the same thing again. There are lines that are parallel here, and we are being asked to find what is the value of B. So considering this, we can see that there is a B here. This is 2B plus 2A. 2B plus 2A. This is 2A minus 15 degrees. This is 55. This is 20. This is A minus 40 degrees. That is what you're given there. So to find angle B, we need to focus with the condition where the angle B is situated, which is here. There is angle B here. But as you can see, it's 2B plus 2A. We also have A there. So meaning to say, whatever equation that I'm going to form where B is, whatever equation that I'm going to form, we are going to also have A in that equation. So you are limited because you are having two unknown values, A and B. So it is best for you to find A first so that you can be able to find the value of B. So that is the condition. If there is any way that you can use direct, of which in this case we do not have such. So to find A is the only or the best option that we can use. We find A first. From which concept now? Which concept can we use there? There are so many ways we can consider angles in a triangle, as we have got alternate angles like this. So we can say the angle 20 degrees here at O is the same as the angle here at P. Alternate what? Alternate angles. So this angle here is what? Is 20 degrees. I think, guys, we are together like this. Alternate angles. We are forming a Z. So now, considering angles in a triangle from O to P to Q. It's a triangle that you're forming there. So from triangle P to Q to O, from that triangle, let us find A. As we can see, we are only having one unknown value in this triangle, which is what? Which is A. That is the only value to be determined. So angles in a triangle, they add up to what? 180 degrees. So combine everything. 20 degrees, this one, plus 2A minus 15 degrees, plus the 55 degrees there. All these angles should add up to 180 degrees. Angles in a triangle from that triangle, right? So these are angles in a triangle, sum of angles. We have formed that. Or you could have used this condition of co-interior angles, just like before. The whole part here at O and the angle at Q combined, those are co-interior angles. So you could have also applied co-interior angles. Remember, they add up to 180. So you just take the 20 degrees, you add to the 55 degrees, you add to 2A minus 15, you obtain what? 180 degrees. But the reason being what? Co-interior angles. But guys, as you can see, it is the same equation. Same thing. So you can form same equation, but from different reasons. Co-interior angles, you can use that. You can use sum of angles in a triangle. It is up to you. All right, so let us continue this one that we have used in the first place. Let us consider our like terms. The like terms, okay, it is just 2A here. So let us consider that and add all the constants that you are given, the angles that you are given, 20 degrees plus 55, which is 75. Then we subtract 15. That was going to give us what? 60. So that's 60 degrees, which is equal to 180. So 2A, to find the value of A there, just subtract the 60 as we are adding, subtract this one. That was going to give us 180 minus 60, which is what? 120. So divide by 2 by 2. That was going to be 60 degrees, which is the value of A. The question is not about A, it is about B. We have the value of A. What about the value of B? It is easier now because we can substitute the A that we have determined or just obtained, which is 60 degrees. In place of A, we can substitute that where there is A. So you can see that in this triangle M to P to O, this triangle, we have B there. So you can use that triangle. So in triangle M to P to O, in this triangle, find B. You're going to find the value of B. You can form an equation. It's fine. It's up to you. Or you can just substitute the A that you have obtained in place of what? in place of A. So if we substitute that, this is A minus 40, A minus 40 degrees. So you put the A, which is 60 there. So 60 minus 40 is what? It's 20. So this whole part here was going to give us 20 degrees. There is 20 degrees, guys. Are we seeing that it is actually telling us that we have got an isosceles triangles there, which is something that you can also tell from what you're given, 20 degrees and also 20 degrees. But anyways, let us just finish our question. Remember, we are substituting the A. This is 2A, 2B plus 2A. So you must multiply 2 times A, 2A, 2 times our A, which is what? 60 degrees. So that's 2 times 60, which is 120. So it simply means this here simply means it is 2B plus the 2A, this one. The 2A gave us what? 120 as a numerical value. So we are no longer using 2A plus, 2B plus 2A. We are now using it as what? 2B plus 120. So that's it, guys. You can see that in this triangle MPO, we only have one unknown value now, which is what? Which is B, because we substituted the A that we obtained. So let us form the same thing, just like here, sum of angles in a triangle. But you are considering a different triangle now. So let's consider that angle 20 degrees plus the 2B plus 120 degrees, 2B plus 120 plus the 20 degrees here is supposed to give us what? 180 degrees angles in a triangle, the sum of angles in a triangle. So that's it. You have formed an equation where we only have B as our unknown. So let's find that B. Add all these and subtract to 180, as we just have one unknown 2B plus the sum of these, that's 20 plus this, which is 140. All right, plus this 20, it's going to be 160. So that's 160, which is equal to 180 degrees. So to find B, we can simply subtract the 160 both sides of our equation. That is going to give us what? 2B, which is equal to, right? So that's 2B. 180 minus 160, that's 20 degrees. Okay, so we've got our B there, which is what? 10 degrees. So if we are to consider where we have got the 10, that is on what? On A. So remember, the question is the value of what? Of B. So B is what? Is 10 degrees. So guys, as you can see, we had to consider finding A. Then after that, you substitute into the given information to find what? The value of B. So if there is any other way, you can use that, as long we are obtaining same answers. That is what matters. All right. On number 8, a right-angled triangle is a triangle with what? All right. So they gave us answers there. A right-angled triangle, a triangle where we have got a 90-degree angle. What are the properties? Inside this triangle, the two remaining angles, they are less than 90 degrees. Meaning to say, these two remaining angles can only be acute angles, because they are less than what? 90 degrees. Once there is a 90 degree inside of that triangle, guys, the remaining angles will be acute. So let's consider what you're given. A, one right angle and two acute angles. So this one was actually direct to what we have. One right angle and two acute angles. So this is the best answer. Anyways, let us see B. One right angle and 2 obtuse. Guys, it cannot happen that there is a 90 degree here. Then we've got an obtuse. An obtuse, remember, is an angle which is more than what? More than 120. I mean, more than 90 degrees. It can be 120, it can be 130, it can be 150. More than 90 degrees. It cannot happen to say we have a 90-degree angle, then there's an angle which is an obtuse like 120 degrees, guys. It cannot happen because that 120 plus 90 on its own, it is more than what? 180 degrees, which is the sum of what? The sum of the angles that we are given in a triangle. So that cannot happen. One right angle, one reflex. Like a reflex can, if we cannot obtain on an obtuse, what about a reflex? A reflex, this is the one, guy, is more than 180 degrees. This is totally out. One right angle, one reflex is totally out. All right. So the best answer there was just going to be on what? On A. So this is it. Some questions can be direct like that. On question number 9, which one of the following triangles is what? Equilateral triangle. Remember, in equilateral, all sides are equal. As we can see on triangle A, all sides are equal. And also the angles, all of the angles are equal. So this is the best one. If we check 60, 60, 60. So the best answer is what? Is A. Equilateral. All right, let's see, there is supposed to be another part here, which is number 10. Which one of the following statements best describes what? A kite. So a kite, we do understand this is all right, we have got something like this, and let's say this is A, B, C, D. The sides AB, AD will be equal. Adjacent sides BC, CD will be equal. Then, if we are to draw the diagonal AC, this diagonal AC, it bisects the diagonal BD, this one, the one that is between the sides which are not equal. Remember, these two are not equal. AB is not equal to BC. So it follows that that angle is the same as the angle, this one at D. Remember the properties, guys, of a kite. And this diagonal AC, this one, it bisects this diagonal BD, meaning to say BD will be divided into 2 equal parts. BD. Not just being bisected, but it will be perpendicular at 90 degrees. And this diagonal AC that we are talking about, it does not just bisect the diagonal BD, no. It also bisects the angles where it is, meaning to say the angle at A, this one, is being divided into 2 equal parts. The angle at C is being divided into 2 equal parts. So this is the main property of the diagonal AC. It bisects the diagonal BD. It bisects the angles where it is, meaning to say the angle A and what? The angle C. So let's check which one can best describe what we have. I think that is all for now. All right. A, the diagonals are perpendicular. So the first part is okay. One diagonal bisects the other diagonal, as we can see. One diagonal, only one diagonal, AC, bisects what? BD. Okay, that statement is actually correct. And one diagonal bisects the angles at the vertices. One, they are saying it is only one diagonal. It is very true. It is only one diagonal, which is AC, which bisects the angles where it is, the angle at A and the angle at what? At C. One, only one. BD does not have those properties. Does not have those properties. So this statement is also true. So as you can see, all these, they are true. Let's see if we, without concluding, let's see on B, the diagonals are perpendicular. This is correct. And bisect each other. This now is wrong. They do not bisect each other. AC is not divided. This AC was not bisected, guys. It is only BD which was bisected. It is only BD which was divided into two equal parts, not AC. So we cannot say they bisect each other. Each other means say both. They're going to be affected. Bisect the angles. Guys, that one is already wrong from that statement. Diagonals are perpendicular and bisect each other is wrong there. Diagonals are perpendicular and do not bisect the angles. Yes, they are perpendicular, but to say they do not, one of them does that condition of what? Bisecting the angles, not all of them. So this statement there becomes wrong. All right, so that is from these. A is the best answer that we can choose. All right, number 11. Which one of the following statements is true for a what? A square. For a square. A square is a trapezium. Guys, a trapezium is a shape of its own properties. It is not to be considered even for a parallelogram. We cannot even put it there. That is why if we check on the properties of quadrilaterals, we had a parallelogram which has shapes under it, such as a square, such as a rhombus, such as a rectangle there. A trapezium, it is on its own, it has its own properties, which is what? One pair of what? Parallel sides. One pair. It is only one pair of what? Of parallel sides. A parallelogram, it is going to be two pairs. This, it's a pair parallel, and this here, it's a pair parallel. So this one is totally out. A rectangle is a square. Can we say that a rectangle is a square? All right. A rectangle has properties similar to a square. Which properties? To say that a square is a parallelogram, a rhombus is a parallelogram, a rectangle is a parallelogram. Those are the properties that a rectangle only shares, which is what? Two pairs of what? Parallel sides. Or we can simply say it, opposite sides are parallel. But a rectangle cannot be a square because a square, it has its own property which cannot be found on a rectangle. And what is that property? Equal sides. All sides are equal. That property cannot be found. A rectangle does not have that property from a square. So we cannot say it is a square because of that, it does not have the property of what? Equal sides. It does not have that property. Some properties are there, but that property alone is not. It is not complete, so you cannot say it is a square. A shape that you say it is something to, let's say it is shape A to shape B. If shape B, this one, we are comparing to shape B, then we find out that shape A is all properties, which are in B, they are there in A. All of the properties and even some other properties, then we can say it is what? It is that shape B. We can say A is shape B. But if we say some properties are not there, we cannot consider that. This is the condition of what? A rectangle. Then C, a rhombus is a square. A rhombus cannot be because of what? The angles are the ones that who affect. The angles of a rhombus, these ones, are not at 90 degrees. For a square, They are at 90 degrees. But this one to say the angle, so it makes it not to be exactly a square. Yes, the sides are equal, but the angles are not at 90 degrees. Both are parallelograms. But when we go to the angles now, it will affect because of that 90 degrees. But let's see. On D, a square is a rectangle. All right. A square is a rectangle. Remember, before we said a rectangle is not a square. What about to say a square is a rectangle? A square has all the properties of a rectangle. It has all. Sides, opposite sides which are parallel, opposite angles which are equal. Only to say it has got the extended part of those opposite angles which are equal. They are all equal now in terms of the side, to say all the sides are equal. So in that case, guys, a square is a rectangle. A square has all the properties that are in a rectangle. Only to say that we can extend in terms of the side to say now those opposite sides that you are saying opposite sides are equal. In a square, all of those sides will be equal. So we can say it is a rectangle. But a rectangle is not a square. Please let's be careful that one on that one. All right. So it has all the properties of what of a rectangle. So that is what we can have on 11. We can say the best answer there is what is D. On question number 12, all right, so let's consider another part, which is question number 12. We are given what is the size of angle A? All right, guys, this is a triangle. Angles in a triangle, they add up to 180 degrees. So subtract these two angles that we are given, the 47 degrees and the 38 degrees, from what? From 180 degrees. Sum of angles in a triangle. So that is it, guys, just like that. So that was going to give us the sum of these. It's 85, and 180 minus 85 is going to give us what? 95 degrees. So the best answer where there is 95 is what? Is B. So it was a direct question. Also, this one, it was a little bit direct, as we can see. Number 13, there is a need of us applying the lines which are parallel here. MN and what? PQ, they are parallel. So what is the value of what? Of Y. Y is here. All right, Y is an exterior angle. So we can figure out about that exterior angle, but let's start with something here, because the exterior angle, which is Y, is supposed to be equal to the sum of the opposite interior, which is the angle at N, which is our N2, and the angle P1. It was supposed to be angle P1 plus angle N2. But we do not have angle P1. This angle P1, we do not have. Where are we going to have this one from? Let's consider the lines that are parallel. As we can see, we are forming what? A Z there. Alternate angles are equal. So this is 35 angle N1. So it is equal also to the 35, which is what? Angle P1. So angle N1 is equal to angle P1, which is 35 degrees. Those are alternate what? Angles, as these two lines are parallel. So that's it. So to find the angle Y, guys, we have got angle P1 is there, 35. We can substitute here. Angle N2 is there, the 127 degrees. That is the remaining angle there, 127. So adding these two, we're going to obtain 162 degrees, okay, which is on what? Which is on A. So if there's any other way, you can use that, apply that condition, and see if you are going to obtain the same values. On number 14, what is the length of the side AB? All right, this is our AB. If we check, the angles they are exactly the same, guys. 74, 74, all right? The 48 here, the 48 here, the 58 here, the 58 here. These are similar figures, similar triangles, where we know that from similar triangles, ratio of sides is supposed to be what? The same. Ratio of corresponding sides is equal throughout from our proportion concept. So from the layout of our triangles, guys, we can see the way even the sides correspond. Y here corresponds to 8. So it's y over 8 is equal to, you take to anyone that corresponds, which is complete. So if you start with this side, like what we did, y over 8, we started with triangle ABC to this triangle. So you're going to start also with this one. So it's 6 over its corresponding side, this side, which is what? Which is 12. If you use 7, it was supposed to be 7 over this corresponding side, which is what? Which is 14. So it is up to you which one are you going to pick, guys. All right. So, but we have got a ratio there. We can find y. Y is the one that represents AB. Or you can even write ABC is similar to this. Then you form the ratio of sides. Still, it's okay. All right. I'm just going to refer to that one. Let me just finish here. So cross multiply to solve for y. That's 12y is equal to 6 times 8. Then to find y, simply divide by what? By 12. So that is it. So y was going to be 6 times 8, which is the product of these two. All right. So then divide, or you can even just reduce. There it's going to be 48 over 12, which is 4. All right. So that's 4 centimeters. 4 centimeters, which is on what? Which is on A. So like I said, answering this question, it is in your hands. You can actually have the triangles that are similar, guys, according to the way that we see the angles that are equal. So you can just name the first triangle. It's your choice. You can choose A, B, C. All right. That's another way that you can answer this. Triangle A, B, C is similar to what? Triangle according to the angles that you have mentioned. So it's A is equal to what? To E. All right. So you name according to equal angles. So A is equal to angle E. Then angle B is equal to what? Angle F. 74 there. So that's F. C is equal to what? G, angle G. So these are the two triangles that are similar. Is similar to. So from there, we can have the ratio of sides from the corresponding sides AB over what? The corresponding side, which is what? E to F. All right. It must be equal to from B to C. All right. You take that as a ratio B to C over what? The corresponding B to C. This is what? F to G. From F to G. It must be the same as from A to C over EG. So that's AC over what? Over EG. It's a ratio that we have formed, which you can complete by substituting. AB is the one that we need. So we can take this ratio where AB is, all right? You equate to any other complete ratio as long as you've got those given dimensions. As you can see, everything, guys, is given according. So you can choose anyone. It is your choice in that case. All right. So you can even just use these two. It is up to you. As long we have got what? AB. So we need to calculate AB. So that's AB over what? EF. From E to F, we have got that one. From E to F. Okay, let me show this one properly. This one, EF, that is what? 8. So you can substitute that one. That's 8 is equal to BC. All right, according to this triangle, BC, from B to C, it is what? It is 6. So that's 6 over what? F to G. From F to G, which is what? Which is 12. You have your ratio, you can find AB. You can also use this one, AC over what? EG, if you want. You're still going to have same answers there. So from this one, guys, you can find your AB direct, all right? Just cross multiply, you are done. 12AB is equal to 6 times 8, then divide by 12. As you can see, that is similar to the previous the previous way of answering. So it was going to be 48 over what? 48 over 12, which is what? Which is 4 centimeters. So that's it. That's the length of the side AB. As you can see, guys, answering these questions so many ways that you can actually use. So many ways. Just apply it properly. Let's consider another question, which is on number 15. We are given this diagram. All right, these sides, all of them, they're equal, as you can see. So it tells us something about the given angles. Remember, angles that are opposite equal sides, they are supposed to be equal. So automatically, if this is y plus 15, which is at C1, it is the same as this angle E2. It is also going to be y plus what? 15 degrees. All right, angles opposite what? All right, so let me just write angle E2 is equal to angle C1. That is angles opposite what? Equal sides. So there we can also use the same thing. Angle B here, angle C here, and this angle E are also equal. This angle is the same as this angle, but okay, no problem. Let's see if we're gonna need it. The question here was the line AEC is what? Is a straight line. What is the size of angle E1? What is the size of angle E1 if AEC is a straight line? Guys, it's already answered because remember I said these two angles are equal from what? Angles opposite equal sides. So there is no need for us to even focus on this triangle above because there we are forming a straight line. It's a straight line that is there. So these two angles are found on a straight line. So we can form an equation there and find the value of what? Of y. Then we can determine our angle E1 because E1 consists of what? Of y. All right, our angle E1, this one, this is our angle E1, this remaining part, that is the outer part, this one, this is our angle E1, which is what? Which is y plus 65 degrees. So that's our angle E1. We must determine the value of y so that we can have our angle E1. So let's find y first. This is the one that I'm explaining to say from the angles on a straight line, we can find angle y there. So find y first. All right, angles on a straight line, angle E1 and E2, they add up to 180 degrees. All right, angles what? On a straight line. Sum of angles on a straight line there. Okay, I'm just going to write in short. So our angle E1, that is y plus 65 degrees, plus angle E2, which is y plus 15, the one that we said it is the same as this one. So y plus 15 degrees is equal to 180 degrees. So let's find the value of y from there. These are like terms, so you can simply collect our like terms, add y to y there. That's 1 plus 1, which is 2. So that was going to give us 2y. Okay, so that is it. This is 1, this is 1 here. So if we add, that's 1 plus 1, which is 2y plus 65 plus 15. That was going to give us 80 degrees, all right? So that is equal to 180. Subtract the 80 as you are adding. So simply subtract this one, both sides of our equation. So that's it. 2y is equal to what? 100. Is that so? 180 minus 80. That is 100 degrees. So divide by 2 by 2. Y is equal to 50 degrees. So don't be tempted there to say you have the answer, then you say your answer is no. The question is the size. What is the size of angle E1? E1. Angle E1, as I illustrated here on top, or said, it is the same as what? Y plus 50, 65. This is what you're given here from our diagram. So conclude now by substituting the value of y that you calculated. You have calculated this. Y is what? 50 degrees. Substitute this value as it is. All right. In place of what? In place of y. So that's it. So in place of y, I'm going to substitute here the 50. So that's 50 plus 65 degrees. That's our angle E1, which is going to give us 115 degrees. Okay, so that's it on A. So that's the best answer that you're going to have for angle E1. So you must be very careful, guys, attempting these questions. As you can see, you must be very careful. So that was our question 15. Question 16, we are given two triangles that are congruent to each other. So these two, they are congruent. RMS, R to M to S. That triangle is congruent to what? TMS. Okay? So remember, from congruent figures, it follows that, okay, if we say triangle RMS, I just want you to see something before we answer the question, guys. Our understanding there is very, very important. They are exactly the same. Exactly the same in which sense? RM is equal to TM. It follows that it is exactly the same. RM, this one, to TM corresponding. Remember, from similar figures, we're saying the ratio of sides, you're considering ratio of sides to be equal. They were considered the corresponding sides, they're supposed to be exactly the same, equal. So RM and TM, they're equal. That is from your understanding of what you're given there. They are supposed to be equal. And as you can see, RM is equal to TM. There's that indication. Then we move on to the angle in between, the angle M, the angle M. As you can see, it must be exactly the same. The angle M in this triangle, in triangle RMS, the angle M that we are talking about is this one inside. This is the angle M. Angle there. It must be equal to the angle M in triangle TMS. In this triangle TMS, where is angle M? This is the angle M that we are talking about, which is the 60 degrees. These two angles, they are equal from this understanding that we are having. Then the last thing also, M to S, the side, MS, MS. The same thing. Common side. MS is our common side. It is a common side. Those are similar. I mean, those are congruent figures. I mean, congruent. You take them side to side, angle to angle, side to side. So that alone can even give you the property to say angle, that will be side, angle, side, as a property to say, okay, what exactly made these to be congruent figures? But our question is not about what made this to be congruent. What is the reason? No, we just want to analyze what is happening. So knowing this, it can be helpful, guys, very, very helpful to answer the question, because they're asking you what is the size, what is the value of what? Of X, the size of X, angle X. Remember, angle M and angle M. From these two different triangles, say these two angles, they are equal. So form an equation from there. From the property of what? Our congruent triangles. From that property, these two angles, they are equal. Form an equation from there. X minus 20 degrees must be exactly the same as what? 60 degrees. There is no way. It's an equation that you have formed. Angle M and angle M from those two triangles. So let's find X. Simply add the 20, both sides of our equation. So that was going to give us X is equal to 80 degrees, just like that. So the best answer there is what is A. So to answer these questions, guys, they can be so many ways. You can figure out another way. As long you're going to have the same answer, that is okay. All right, number 17. We were given that M, N, or P from M to N to O to P. It is what? A parallelogram. Remember, opposite sides, they are supposed to be parallel. Opposite sides, parallel and equal. Then we have got something here. QR is parallel to MO. It is something that is an adjustment from Q to R, M to O. All right, that part also, it is what? Parallel. What is the length of MO? From M to O, what is that length? All right, there we can simply use similar figures. Okay, why similar figures here? Since we have these two lines which are parallel, there is triangle NO to any MO, this one, and any Q to R, these two. They have got something in common. What is it? The first triangle and the second triangle, which is the bigger one, this one, they have something in common. Let's figure out. N is the common angle, this one, for the two triangles, the bigger triangle and the smaller one. So I'm comparing two triangles, N, Q, and R there, and triangle N, M, O. I'm comparing these two. So you see that N is the common angle, that one. And angle N is common. All right. Then, if we move on, because of the parallel lines that we are given there, you notice that the angle that is being formed here, which is M2 and angle Q1, there are lines that are parallel like this. From the transversal line, there's an angle inside the lines that are parallel and the one that is outside. Remember, corresponding angles where we form F. It tells us that the angle Q1 is the same as angle M2. They're exactly the same. Corresponding angles. The same thing happening to angle R1 of this triangle on top, which is triangle NQR. It is the same as angle O1. Corresponding angles again. One is inside, other one outside of the what? Parallel lines. So you can say angle R1 is the same as what? Angle O1. Corresponding angles again. Angle, all the angles. We are considering the angles, guys. Automatically, when we have got this condition, it is of what? Similar figures. Because similar figures are what? Are equiangular. Remember, they are equiangular from equal angles. From those equal angles, you can name the triangles that are similar. N, Q, R. In that order, N, Q, R is similar to what? To triangle. In that order, N, M, O. In that order, N, M to O. The way that you mentioned the equal angles, because someone can name this triangle RQN, so it will be OMN. You have to be very careful in terms of the order there, the way that you're going to put your triangles. So if they are similar, we can use the ratio of sides just like before. Ratio of what? Sides. Supposed to be the same throughout. Ratio of what? Corresponding sides. It's supposed to be the same. Remember how we had that one, guys. You need to calculate MO. So we're going to have N to Q over what? Corresponding N to M must be equal to Q to R over the corresponding M to what? M to O. You can use this part if it is complete on the diagram, but if not, equate to the last one, because we also have from N to R there, which is the same as from N to O. Ratio of sides. Where there is MO, the one that you're supposed to calculate, it is here. So you're going to use this ratio with anyone that is complete. So you're supposed to figure out which one is complete. All right. Any Q, we have it. Any Q is there. What about any M? From N to M, do we have that one? So someone can say, no, but we have it. From which concept? Remember, we are told that this here, it's an indication here that N to Q is equal to QM. So if this is 6 centimeters, this is also 6 centimeters. So at the end, NM, the whole of that line, we simply add 6 plus 6, which is 12 centimeters. So it is the same 12 centimeters this side. So we have the length of NM, it is there. What about QR, as it is part of our ratio? Do we have it? From Q to R, all right, this is Q here to R, it is there. So guys, this is complete. QR is there. So that is it, guys. You want to calculate what? MO, given these three. So we can simply use this part. We can simply use this part of our ratio. So using that part of our ratio, let us substitute N to Q as from our diagram. N to Q is what? 6 centimeters. From N to M, all right, the wall of the line here from N to M, this is the part that I was indicating. The wall of this part is what? 12 centimeters, the 6 plus 6 from equal sides that we are given. So that's 12. This is equal to Q to R. From Q to R, we also have that one. Q to R is given as what? 8 centimeters. So that was 8 centimeters. So that's it, guys. We can calculate our MO. So we have an equation. Simply solve, guys. Cross multiply the 6 times MO, which is 6 MO is equal to 8 times what? 8 times 12. Then we're going to simply divide by what? By 6 to get rid of that 6 here. So cancel. That's MO is 8 times 12, which is something like 96. Then 96 divided by 6 was going to give us 16 centimeters. Or you can just use your calculator direct. So 16 centimeters, that is the best answer which we are going to consider on what? Which we are going to consider on D. All right, let's see on another part, number 18. We are given which one of the following transformations represents the reflection in the x-axis. So a reflection in the x-axis, remember it is just transposing, like to say the units from where the point or from where the object is to the mirror line, which is our x-axis. We are supposed to move the same units going up. So that will be 1, 2. So our image is supposed to be there at, this is 2, this is 2. At 2, 2, our image is supposed to be here at 2, 2. That is where we are supposed to see it, along the x-axis. So which one best describes, all right, at 2, 2. So this one, it is now, this, guys, the way that it is here, they interchanged, like the sign, the way that it is not supposed to change. The sign is supposed to remain the same way. Even here, the way you see that, that is the one, because a reflection, you see this one, it will go up. So this here, okay, is gonna be down, and this one is gonna be found up, so it will be there up. So the best one to describe is what is a C at point 2, 2, but also the sign here, the way that it is. So the best answer was going to be what? Was going to be C. A reflection in the x-axis. A reflection in the x-axis. So if it is, let me give best description that we can use. So let's say we've got something like this. All right. This is what we are trying to say. This is A, this is B. When you reflect it in the x-axis, it follows that the A will move distance, a certain distance to the x-axis. It will move the same distance going up. So you find out that here it will be our A bar. The B, it will move the same distance to the x-axis. From the x-axis to the image, same distance. So you find B bar on the top there. Whereas the one now, a vice versa in terms of how it was. A to B, A to B. So it is the same thing of how this shape here looks like. Here to say this thing here, this one, is the one that it will be, the one that you'll be seeing down here. Then this other section, this one, is the one that you see on the other hand, guys, like the way that we are seeing on what? On C. Take note of your reflection, the way that it is. They can give you a shape. You must consider also the shape, the way that it is. All right, so the best answer was supposed to be what? Was supposed to be on C. Let's consider another question, which is 19. On question number 19, which two shapes are reflections of each other in the line y is equal to x? So remember, the line y is equal to x, subdivide our graph into two equal parts like that. So if we take it that way, let us just try to have a sketch of the line y is equal to x. All right, so it is supposed to be, it subdivides when x is minus 3, y is minus 3, when x is minus 2, y is minus 2, when x is, it will be in between. All right, supposed to be like this. So this is the condition of our line. It does not, okay, it is not giving the same here. Let me adjust here. Supposed to be, okay, this one supposed to be somewhere like this, in between. It's only that okay, but it's going there before we start to blame the question paper to say the way. All right, something like this. So you see that 0, 0, when x is 1, y is 1. So it will be exactly at the same point. Y is equal to x. They're the same. 2 versus 2, 3 versus 3, something like that. So a reflection in this line, guys, interchanges the points. In which manner? if I have a point which is xy, it will be transformed to yx. So what I'm trying to say, if a point is referred as 2, 3 originally, it will change. What was your x value becomes the y value. What was your y value becomes your x value on the presentation. So this will be 3, 2 like this. That's how the points will be transformed along this line. So which one best describes that, where points are transformed in that manner? Is it between P and R? P and R, these ones, they can be best described as a reflection along the y-axis. These two, not this one, but along the y-axis. So P and R, guys, is total out without wasting our time here. S and T, they are on the same side of the mirror line. It cannot happen that there is a mirror line, then shapes are found on the same side of the mirror line where it is. So S and T, it is totally out. R and T, let's check. R and T, they are also on the same side of the mirror line, only the other part, that one is totally out. All right, R and T is totally out. Then Q and R, let's check our Q and R there. What is happening between what? The last one is what? Q and R. Q and R, these two. All right, so if we check here, the other portion of R is on the other side, and the other one is on the other side of the mirror line, which is the same as on Q, the other portion, the other portion. But let's analyze properly this condition to say, is it happening that the x values and y values are interchanging? We can just take an example of this point on R, this one. This one. It is what? 3, 4. It is 3, 4. So on the image which is here, it must interchange. Remember, 2, 3, 3, 2. Is it that it is going to interchange here? What are the coordinates of this point? Because it is the same point. This one is the same as this one. It is now given as what? X is 4, y is 3. It is 4, 3. Exactly this condition. X and y just interchanged. Okay, look for another one to verify. Just look for another one which corresponds. This one, this corner here, this vertex, this one, this one. It is the same as this corner here, this one. What are the coordinates here? 2 versus what? 2 versus 4. That coordinate that I just marked there is 2 versus 4. Is it interchanging this side? Let's consider it. It's 4 versus what? 4 versus 2. As we can see, it is 2 from the y-axis. It is actually giving us that condition. It is corresponding 4 versus what? 4 versus 2. As we can see, 2, 4, 4, 2. It was 3, 4, it changed. 4, it is interchanging like this. That interchange is there. X and y, they do interchange. It only happens in the line of y is equal to x. It only happens in that line. Only. So Q and R. Q and R is the best. It best describes what we are looking for. So this is it. So the best answer there was going to be on D. All right, that is gonna be on D. So this is it on number 19, according to what we are given. So guys, transformation, yeah, transformation, and yeah, transformation. It's only that I did not also explain that much in terms of our introductions. We're going to find time dwell into that transformation. You understand, guys, a lot of things that you can learn from your transformation. It is one of the easiest topics if you understand the basics. All right. The point P is transformed to its image. Describe the rule used by transformation P to its image. All right. A, translated 2 units up, 4 units to the left. Okay, let's see. This is our P, which is 3 minus 1. So when we say 4 units up is for the y-axis. So y-axis, when going up, it's positive. When going down, you subtract. So when it is up, you add. It's the y values. So you are supposed to add 4. They said what? 2 units up. So if we add 2, then 4 units to the left. We are going to the left. There's a point which is at 3 minus 1. Then that point is going to the left. What are we going to do? We subtract those units that are going to the left. So it's 4 units to the left. On the x values are affected. So if we subtract 4 here, are we going to have this? Okay, 3 minus 4. What is 3 minus 4? That's minus 1. 3 minus 4. Minus 2 plus, minus 1 plus 2, that's a 1. Guys, it is totally different from the image that we are expecting from that information. So A is totally wrong. Okay, let's move on to condition B and see condition B. Condition B, they said translated 4 units to the left. Guys, I've explained to the left, it affects the x values. So we subtract, that's to the left, the x values, x, y. So x minus 4. Okay, and 2 units up, the y values, add, going up, so we add 2. Is it what you're given there? 3 minus 4, that's minus 1. Minus 1 plus 2, that's 1. Guys, it is not our image P. This is totally wrong. Let's move on to C. Translated 2 units to the left. 2 units to the left. Okay, let's remove this. Remember, to the left, we subtract. So you're going to subtract 2 units. And 4 units up, we add. So plus 4, let's see. 3 minus 2, that's what? That's 1. 3 minus 2. You consider that condition and see if it's going to give you the answer. So 3 minus 2, it's what? It's 1. Minus 1 plus 4, that is what? That is 3. Is it the image P that is given there? Exactly the one. So this is the best answer, C. Okay, let's just see the last one, which is D. D, they are saying what? Translated 4 units up, 4 units up. It is for the y values, 4 units up, the y values, you add 4. 2 units to the left, 2 units to the left, we subtract what? We subtract 1 here. We're going to subtract 1. All right. So that is 4 units up. All right. So that is going to, but the translation concept there. All right. And 4 units up. Translated 4 units up and 2 units to the left. So if we check the D, here's something that we want. But the case of a D now is the sequence. There we can have the sequence there to say, why is it that we translated, we moved 2 units to the left and then we moved up. Remember, points. If we consider points, it's x followed by y. So x is affected. But D, they started with y there. So the sequence of points, or the sequence how the points are given, is the one that will make us not to say it is the correct answer. So D is affected because of the sequence, but in terms of the layout of the answers, guys, it was going to be correct. In fact, on those other question papers that you even do, they won't even give you something that is similar like this. No. But this one, guys, here, remember here, guys, they want to know exactly, do you actually understand what you're doing, or you're just doing maths? They want you to know, do you know this maths? The basics of it. So in terms of how points are moved, and the best option was going to be this one. We start with x followed by y. X followed by y. X followed by Y. Take note, guys. X followed by Y. If we take it that way, then we'll see that C will be the best answer. Okay, then let's consider question number 21. The point P there is the image. All right, P bar is the image of what? It is the image of P. A reflection in the x-axis. All right, let's talk about that reflection in the x-axis. I think I talked about the one of y is equal to x. A reflection in the x-axis, guys, is one of the easiest one. This is our x-axis. So what happens is that if a point is here, this is A and this is A bar, along the x-axis, all right, it will be the same value of x. The value of x is the same, but the y value changes. So if this here is x, y like this will be x minus y. The x value will be the same, but the y value changes. That is the only condition. So when it is reflected along the x-axis, look into that. X remains the same, so x must remain as what? As minus 2. But y is affected by a negative. So y, you multiply it by negative. Negative 7 is going to be what? Positive 7. So P is minus 2, 7. Minus 2, 7, which is what? Which is A. A is the best answer. That is a reflection in the x-axis. A reflection in the y-axis is the opposite of that. So the opposite is where the x changes. If it is x, y, the x is the one that changes. It will be minus x, y remains as it is. That is about the y-axis. About the x-axis, x remains as it is, y changes. If you just understand, you are done with the reflection about x-axis and y-axis, guys. You are done. You are done. Those are the two conditions that will be asked now and again. They will be repeating that. Look what is happening here. What are the coordinates of the image of this point Q? So Q is given as 3, negative 5. When reflected in the what? In the x-axis, the first thing, let's start with the reflection in the x-axis. What did I say about this reflection? It affects the y value. So meaning to say it was going to be 3, then the y value is affected by a negative. So it will be 3, 5. It will be 3, 5. This is a reflection, this one, in the reflection, this one, in the what? In the x-axis. This is the one. In the x-axis. This is the one. And translated 2 units to the left, it's another one. Let's transform to the left. To the left, like I said, you subtract. So how many units? 2. On the x value, subtract 2. So 3 minus 2 is what? It's 1. So the final point will be 1, 5. 3 minus 2 is what? It's 1. So the final point is going to be what? It's going to be 1, 5. So that's the image of what? That's the image of Q. 1, 5, 1, 5, 1, 5, which is what? Which is C. Guys, you know, transformation is one of the easiest topic if we find time to talk about this topic. You will see, guys, it's just like a follow around. You don't need a lot of things. You just follow around. It will be one thing, one thing, one thing, one thing. It will be one thing throughout. Look at this one. What are they saying here? The point what? XY. There is a point which is called XY. What happened to it? Reflected in the y-axis. Let's start with that one. What did I say about reflection in the y-axis? Reflection in the y-axis, it changes the x value to a minus. So meaning to say, this point was going to change into minus. So it was going to be minus x, y like this. This is reflection in the what? In the y-axis as we are given first. And translated 1 unit downwards, down, down, down. We are going down. These are the y values. Up, those are the y values. You add, down, you subtract. So going down, you subtract y values. So on the y value, we are going to subtract 1. So that's it. So our point was going to be minus x, y minus 1. Guys, transformation. I don't know how can I explain. So from this image, which is xy, the final answer will be this one. So let's look for that condition xy to this. So the best answer was going to be on what? On B. on B. So 23, the best answer was going to be B. Just like that. So these questions, they repeat if you understand these guys. So let's see what we have on question number 24. We can see that these transformations, guys, they just repeat, okay? On question number 24, line AB with A as a point and another point B is reflected in the line y is equal to x. Okay, remember I talked about these properties of the line y is equal to x. The transformation interchanges these y and x. So that is the condition. So what are the coordinates of these images, A bar and what, B bar? So guys, this one is direct and straightforward. We just have to interchange the coordinates x and y. So y is going to be our x on that coordinate. So it's going to be 9, -5. You just interchange. Then b is just going to be 2 versus 1. You interchange. So which one is the one that has got this condition? 9 and -5, 2 and 1. That is on what? On D. All right, so the best answer was going to be D. That's question 24. 25. We are given the diagram. Then there is triangle X, Y, Z. All right, are the coordinates of triangle. This one, X, Y, Z. Where is it? X. We do not have that triangle yet. It's not given. There is no triangle X, Y, Z. Let's try to figure it out. -2, 4. That's our X. -2 versus 4. -2 versus 4 is up there. The X value is -2. Y is 4. So they meet here. All right. There is another point A there. Okay, let's just put our X. Okay. Y is what? -3 versus 3. X is -3 and Y is 3. Okay. It's at B. Okay. There's already another point. That's Y there. And Z is -1 versus 1. All right. -1 on X, 1 on Y. It's going to be where point C is. All right. So our triangle, guys, XYZ. XYZ. It is exactly where triangle ABC is. All right. That is where it is found. So the question here, it is that which triangle represents the reflection of triangle XYZ, the one that has got these coordinates, in the line y is equal to x. We are back, guys, to the same line y is equal to x. All right, let us just have a sketch about this line. Remember, same coordinates, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, like that. It will be the x value is the same as the y value. So the line was going to be like this. This is the line of y is equal to x. So with this line, okay, which is the image? By just looking into the object, remember our object, it's XYZ. ABC cannot be the image, guys. It is where our XYZ is. So that one cannot be, you cannot say there's a reflection that occurred. So ABC is totally out. We have triangle ABC. It is totally out. All right. We have got H to G and J, this triangle, guys. Remember, guys, reflection about the line y is equal to x. If the point is here, it's going to move 90 degrees like that. So we have a reflection somewhere there. So you cannot have the triangle here, guys, and its reflection is here, or this side. So these two triangles, they are totally out again. The triangle, this one and this one, they are totally out by just looking, guys. So that's, which one is this? D, E, F. So D, E, F is totally out. And this one that has got H, it's what? G, H, I is totally out. All right. Then we are left with what? K, L, M. All right. Can we say it is a reflection of that triangle? Okay. By just looking, we can see it's a reflection along the line of y is equal to x according to this interpretation. Or we can look into the points. Remember what I said about the transformation of the line y is equal to x, the points interchange. So if we look into the point x, all right, our point x as we are given here, these are the points x, it interchanges, its image interchanges. So it will interchange, we just interchange those values. So it's going to be 4 minus 2. Do we have the point 4 minus 2? X is 4, y is minus 2. This is the point what? This is the point L. The point y also interchanges. So it will be 3 minus what? Minus 3. 3 minus 3. This is exactly what we have here. 3 versus minus 3. That is our point what? Our point M. The point Z also interchanges. So it will be 1 versus minus 1, which is our point K. So truly, it is the exact thing that we want. All right. So if, guys, there was no even need of you just representing these points, you can go straight forward. They told you it's a reflection in the line of y is equal to x. Use this interpretation. Then you check which triangle has got these coordinates. You find out it is what? This other triangle, which is LMK. So that is the triangle that we are going to use, which is exactly the one on what? On D. So D is the best answer there. So there was, guys, there was no need of even indicating those points, but indicating the points on the diagram, you can even look into the way the triangles are given. Then you can tell that this one is not, this one is not. Therefore, the right answer is this one. So many ways that you can actually use to answer transformation. Like I said, guys, we're going to need time to talk about this topic in detail so that you understand all the basics. On number 26, there is a triangle which is ABC, and it is an equilateral triangle, meaning to say all the sides that you're given, they're the same. So if it is ABC, AB 5 centimeters, so it means throughout this triangle, all these sides will be what? 5 centimeters, equilateral triangle. What is the perimeter of triangle ABC, guys? Perimeter, distance right around the shape. So you simply add all the sides, 5 plus 5 plus what? Plus 5. So that was 15 centimeters, all right? The centimeters, the units, perimeter. Perimeter in what? In centimeters. The cubic centimeters for what? For volume, these ones. So it cannot be 15 cubic centimeters. So be very careful on the units. On number 27, PQRS is a rectangle, all right? So if it is a rectangle, what is the formula to calculate the area, all right? Area of a rectangle, guys, that's length times what? Breadth. Length times breadth, okay? This one is for a right angled triangle. Length plus breadth, there is no formula like that. 2 into length plus breadth is for the perimeter. This one, it is for the perimeter. There they want area, not perimeter. So the best answer is what? Is B. All right, let's consider number 28. 2 pi r is used to calculate what? This is the circumference of a circle, all right? Or circumference or perimeter of a circle. So it can be 2 pi r. Remember, 2 times radius gives us what? The diameter. So it can also be written as pi d. So it is for the what? The perimeter, the circumference of what? Of a circle. So the best answer there is what? Is B. All right, let's see on number 28, what is the formula to calculate the area of a circle? That is what? Pi r squared. All right, pi r squared, which is D. This one is pi squared. No, this is wrong. Okay, so that is pi r squared, a circle. A circle has got this area. What is the diameter? Round off to 2 decimal places. So guys, we just use the same concept. Remember here we just mentioned this is what? The area of a circle. So from that area of a circle, pi r squared, you are given the area this time, 198 is equal to pi r squared. So you can calculate the radius from there, just divide by what? By pi. Okay, so r squared is equal to this 198 over what? Over pi. So to find the radius, introduce the square root to get rid of what? The square that you're given. So that's our radius, the square root of this. But here they need you to calculate what? The diameter. Diameter is equal to 2 times the radius. So whatever that you're going to get here, multiply it by what? By 2. You are going to get the diameter. Just like that. So that's it. So the radius times 2 gives us what? The diameter. So it's 2 times our radius. Our radius is what? The square root of 198 over pi, which is shift. You press this one, it's gonna give us pi. So the answer's rounded off to 2 decimal places. Let's fix our calculator to 2 decimal places. We press 2. So that's 15,88. 15,88. The units there in what? Centimeters. Okay, that was square centimeters. So this must be in centimeters. So the best answer that we're going to have was supposed to be on what? On B. So that was our question. All right, seems like there is another question here. Okay, 30. Okay, that's it, number 30. So that's 30. Let's move on to 31. So in this case, they're asking for the perimeter, the distance right around the shape. So if we consider the diagram, we can see that we have got missing values from A to F, from F to E, from E to D, from D to C. So there are so many ways that you can use, so many ways that can be used. But if we can analyze in a proper way, we can see that we have a triangle that is in this manner here. It is actually a triangle, this one. So from the properties, I mean a rectangle. Why am I talking about a triangle, guys? There's a rectangle there. From the properties of a rectangle, we know that the opposite sides are supposed to be equal. So noting that concept alone tells us that D to C, this one, from D to C, it is the same thing that we are having from here to here. So you can even call it X. Let's just call it X from D to C. Okay. So if the whole of the line here is 20 centimeters or 20 units according to what we are given, it means we can find this remaining part from the 20. It will be 20 minus what? 20 minus X. We subtract this. So it simply gives us the same 20. I just want us to analyze to say this is the same line that you're having here. Same thing from the rectangle concept. So if this is 20 minus X, it follows that this F that we are seeing, F to E, this one from F to E, it is 20 minus X. It is simply that 20 minus X, which is this one. The X concept that we are seeing on what? On DC. It is 20 minus DC. Or you can just say X. Same concept that is happening on this part here, on this one. From A to F, you can just call it Y. It's another side, so you cannot use X. You can just call it Y there. So if the whole of this line, this whole line here, is 25, what does it mean? It means the remaining part here, it is what? 25 minus Y. 25 minus that AF. So you can write in terms of those letters A to F, or you can just put X. So if you are going to calculate the perimeter, guys, you're going to see that those X that you inserted and the Y that you inserted, they are going to cancel out. All right, let's see. This one is D to C, which is X plus from C to B, which is what? Which is 25. Then from B to A, instead of us saying this is x plus 21 plus 20 minus x, guys, this minus x and plus x is going to cancel. So it's what? Is 20. The whole of that line is what? Is 20. From A to F, which is what? Which is y. Then from F to E, which is what? 20 minus x. Then we have got the remaining part from E to what? From E to D. You add everything that you see there. So from E to D, it's what? 25 minus y. So as we can see, this x and the minus x cancels. The y and the minus y cancels. So at the end, your perimeter was going to be what? The sum of the given numbers that we have there, and that was going to add up to 90, which is what? 90 units, as we are not given the units to say it's centimeters or what. So it is going to be 90 units, just like that. So you can use it in terms of those letters that are already given, like A from D to C and so on. Or you can just introduce X and Y, you analyze that way. So 90 is on what? On D. So that was the best answer that we can use for that perimeter of the given shape. So perimeter, yeah, they can play around with the diagram in that manner, guys. We have got a kite on number 32. PQRS is a kite. Okay. So remember the properties of a kite. So here, let's see, what do they want? They want the area. So without wasting the time, they gave us from P to R this diagonal, which is what? 16 centimeters. Okay, this is millimeters. There's a need of us to convert. The answer is in what? Square centimeters. So remember, 1 centimeter is 10 millimeters. So to convert to centimeters, simply divide by what? By 10. So that was going to give us what? 3 centimeters, which is our TS. From T to S, they gave us this piece from T to S, 3 centimeters. Okay, so they want to you to calculate the area. Okay, the area of a kite can be taken if you have got the diagonals like that. You can use this formula, half the product of diagonals. Half product of what? Diagonals. So you just need to multiply the product of the diagonals, which is according to our diagram, P to R and QS. But we do not have this diagonal QS. We have got the piece, the part of it. Remember what happens, guys, from the previous illustration that we referred before? We said one of these diagonals, it bisects this PR, this one. It bisects the other diagonal into 2. So meaning to say, if this here is 3 centimeters, also from T to Q, it is what? 3 centimeters. So therefore, we have got the length of the whole diagonal, which is what? 6 centimeters. So we can calculate our area as it is half the product of the diagonals. Our diagonals is what? PR times QS. Those are our diagonals. So let's substitute half of what? From P to R, it is 16. In centimeters, remember the units in centimeters. From Q to S, it is what? 6 centimeters. So that was going to give us the area in that case. All right. So in this case, guys, if we were to simplify, that was going to give us 48. This is 8, then by 6, which is what? Which is 48 in square centimeters, as we converted these ones to centimeters. So therefore, we have got this our area in what? Square centimeters. So that's it on question number 32. We've got 48 square centimeters as our area. So there are so many ways, guys. You can even subdivide this into triangles. You find the triangle, or you can just have two triangles, this one below and that one above. Whatever way that you're going to use, you must obtain same answers for that area, because, guys, it's geometry. So many ways. Number 33, the diagram that we see here represents three quarters of a circle, the diameter being 30 centimeters. So what is the area of the shaded part, which is three-quarters of the circle? So the area is simply what? Three-quarters of a circle. The area of a circle is what? Pi r squared, just like that. You have your area there. It's three-quarters of the circle. The diameter is 30 centimeters, so therefore our radius is what? Diameter over 2. That is 30 centimeters over 2, which is what? 15 centimeters. So we can calculate our area 3 over 4 times pi times our radius 15 squared. That's radius squared. So that was going to give us the area to the nearest whole number. All right, so let's see. So here I'm just gonna fix my calculator to the normal mode. Let's see. So we had 3 over 4 times pi, which is times 15 squared to the exponent of 2. So this is it as a decimal. As you can see, that was going to be 530,143 to the nearest whole number. As we can see, 1 cannot change, guys. 1 is less than 5, so 1 cannot have an effect on that 0. So it will remain as what? As 530 to the nearest whole number as we are given. So that was going to give us 530. We are talking about what? Area in square centimeters. So that's it to the nearest what? To the nearest whole number. So 530 square centimeters. That is on what? On B. So that is how these questions can be given as, just be careful on how to attempt them. On question number 34, we are given that DEFG is a rhombus. There is a rhombus. And these are the diagonals. What is the perimeter of the rhombus? Okay, so remember, on the properties of a rhombus, guys, these diagonals, they bisect each other. And they do not just bisect each other, but they do bisect each other at 90 degrees. At 90 degrees. So this one, if we have got this one as D, E, F to G like that, they gave us DF, D to F 6. The whole of this one is 6. But remember, these diagonals, they bisect each other. So 6 divided by 2 is going to be what? 3x. So this is 3x. This is 3x. From E to G, it is 0, 0.08. Okay, in meters there. So you must convert to centimeters because these answers are in centimeters. 1 meter is 100 centimeters, remember. So multiply by what? By 100. So that was going to give us 8. So you were going to have 8x centimeters as a diagonal from E to what? From E to G. But we need half of it because these diagonals, they do bisect each other. So 8x divided by 2, it was going to give us what? 4x. 4x. The whole of this is what? 8x. The same as what we had. This is what we have there. So for us to determine the perimeter is the distance right around the shape. Remember a rhombus, all these sides will be equal in terms of the sides. It will be equal. So finding one, we are done. Calculating one of these sides, we're done. So the question is, how can we calculate it? Since these diagonals, they meet or they bisect here at what? 90 degrees. We can see that the triangle that is being formed will be a right-angled triangle where you can calculate the third side of that triangle using what? Pythagoras theorem. We are in a right-angled triangle. This is a hypotenuse. So hypotenuse squared is equal to a squared plus b squared. Or you can simply use your Pythagorean triples. This is 3, 4. This must be what? 5. So it must be 5x. But anyways, you can simply use your Pythagoras, meaning to say gf squared, our hypotenuse, is equal to, let's just say this is O. So it's going to be OG squared plus OF squared, which is what? 4x squared plus 3x squared. So 4x squared, that's 16x squared plus 9x squared. You add 16 plus 9, that is what? 25x squared. So that's our GF squared. So to find GF, you introduce the square root both sides, guys. It was same, one and the same. Or you can simply use what? The Pythagorean triples, 3, 4, 5. Okay, anyways, introducing the square root, that was going to give us the length of GF, which is square root of 25, that's 5, square root of x squared, which is x. So this is 5x, meaning to say each side, remember you're talking about a rhombus, same, supposed to be having what? Equal length throughout. So in that case, guys, we can have the perimeter. The perimeter is what? Distance right around the shape. You simply have to add 5x plus 5x plus 5x, all of them, or you can use 4 times s as these sides are the same. So that's 4 times one side, which is 5x. 4 times 5x, that's going to be 20x centimeters perimeter, same units. So that's it. The best answer was going to be what? On B. Or just add 5x plus 5x plus 5x plus 5x. They're testing you there on the properties. Do you know your properties of the shapes and also your Pythagoras theorem? There is a wheel which is of a toy and has a diameter of 5 centimeters on question number 35. How many times will the wheel turn if the car moves what? 2 meters. So the car is going to cover 2 meters, the distance. So it is like a wheel, it is rotating along. So what is the perimeter of the wheel so that it can be written as a length? We need its perimeter because as we are given length, length is related to perimeter. So we simply need its perimeter. First, what is the perimeter of what? Of the wheel. Okay, these are in centimeters. Okay, so let's find our perimeter. Remember I said perimeter is 2 pi r or pi d. 2 times radius gives us what? Diameter. So you can use pi d, which is pi times the diameter, 5 centimeters. So it was going to be 5 pi centimeters. This is our perimeter in centimeters. So in a line which is 2 meters, to cover that distance, you must divide. How many times? So divide. So it's 2 meters over what? 5 pi centimeters. These units cannot work. They are not the same. We cannot divide such condition. So we must change the meters to centimeters or centimeters to meters. Guys, it's easier to change meters to centimeters as we have got what? 100 centimeters in a meter. So multiply by 100. This is the same as we've got 200 centimeters over 5 pi centimeters. This can cancel. So 200 divided by 5 pi is what? 200 over 5 pi. So this is 12,7 something, 12,7 something, something, and so on. So to the nearest whole number that was going to affect 7 is more than 5, it can change this one into 13. So thus we've got 13 times 13, which is on what? On D. So you see, guys, they'll be testing you. Do you know your properties? Number 36. The volume of a cube is given as 64 cubic centimeters. Remember the volume of a cube, side to the exponent of 3, side times side, as they are equal. So what is the length of a side of the cube in millimeters? Guys, if volume is side to the exponent of 3, you just take that. Side to the exponent of 3 is equal to what? The volume is already given. So find the side. Get rid of what? The cube root. I mean the cube there, by introducing the cube root, both sides. So that's going to give us the side of what? The cube root of 64, which is 4. Remember, these are cubic centimeters. So the length or the side must be 4 centimeters. But they said in millimeters. 1 centimeter, 10 millimeters. So simply multiply by 10. That was going to give us what? 40 millimeters, which is on what? On C. All right. So that's simple conversion. Simple conversion, which is to be used later on. Number 37, what is the surface area of the rectangular prism? All right, they are all in centimeters. All right, so remember, a rectangular prism, the surface area, guys, is gonna be 2 into, right? Remember, we've got length, breadth, and height. So it's gonna be length times breadth, breadth times height, length times what? Length times height. You just take everything as it is. Length and breadth, breadth and height, length and breadth. So that is it. So our length is 10, and the breadth in this case is what? Is 6. The height going up is what? Is 4. So let us substitute. Our area is going to be 2 into the length, which is 10, times the breadth, which is 6, plus breadth times length, or length, guys, where am I getting? This is h, isn't it? Breadth, height, breadth, height. This is h, breadth times height, breadth times height. Let's correct this one. So the breadth is what? 6, and the height is what? Is 4. Then we have got the length and the height. The length and the height. The length is 10. The height is what? Is 4. Okay, so that's it. We have got your area there. So it's going to be 2 into, you can combine. This is 60, 24. This is 40. So that was going to give us, okay, the product. If you multiply, add these, then multiply by what? By 2. Okay, sorry for that. It was going to give us 248. So 248, this is area, centimeters. So it's going to be square centimeters. So be careful about the units. In this case, they gave us everything in square centimeters. So it's okay. So 248, that is on what? On D. On number 38, what is the surface area of the prism? So surface area, guys, we've got to calculate everything that you see. There is a triangle here, which is the same as this one. So there are 2 triangles. 2 triangles. So remember, area of a triangle is half base times perpendicular height. Half base times perpendicular height. So there are 2 triangles which are the same. So the moment you multiply it by 2, this is going to cancel. All right, anyways, let me just leave it like that. So it's going to be 2 times half of what? The base times perpendicular height. The base and the perpendicular height at what? 90 degrees, 15, and what? 15 times 8. So this is for what? The 2 triangles, okay? If you check properly, there is a rectangle. Let's say here, let's say this is A, B, C, D. A, B, C, A, B, C, D, this one, on the base, this one. It's a rectangle that we can see. It has area, length times what? Length times breadth. So it's going to be 25 times 15. This one below. 25 times what? 25 times 15 plus, there is also, remember we took this triangle, there is also a rectangle. Let's say this is A, B, C, D, this is E, this is F. If you check, there is, all right, so this one we said A, B, C, D. This is our A, B, C, D. All right, there is this one from B to C to E to F. That one, it's a rectangle, that one. Length times breadth again, from B to C to E to what? To F. Length 25. The breadth, as we are going there, is what? 17. So that's 25 times what? 17. If you check, there's another one that is remaining behind there. Behind here. Behind there, the corner. This one. It's a rectangle also, which is made up of what? A, D, E, F. This one. A, B, D, A, B, D, E, F. This one. All right, so you must add it also. That's A to B, to D, sorry, to D, to E, to F. So that's again length times breadth. This length here, A to D, is the same as what? B to C. So that's 25. This is the same as what? 25 centimeters. So it's going to be 25 times going up, which is the 8 centimeters. So we have used everything, guys. The two triangles, we considered this rectangle on the base, this rectangle on the face that we see, then the other one which is behind there. Everything must be considered. Everything. So if there's anything that is missing, guys, I don't know, but everything is there. Everything. I have mentioned everything. The two triangles. So combine these, guys. We're going to find your area at the end. All right. This cancels 15 and 8 was going to give us 120 plus 25 and 15. That's 375. 25 and 17, which is 425, 28, 25 and 8, which was going to be 200. Then we add everything. That was going to give us 1,120. Area, square centimeters, all right? Square units. So that's square centimeters, which is what? Which is on A, all right? So the best answer there, we have it on what? On A. So that is how we can answer or attempt this type of a question. On number 39, they gave us a cylinder. Which formula is used to determine the surface area of a cylinder? So remember, a cylinder, there are two circles. There's a circle here. So it's 2 pi r squared for a circle. Then there is the curved part, which is the 2 pi r h. So it's called 2 pi r h. All right. So the best answer there was direct, guys, which is on what? Which is on B. Area of two circles plus the curved part gives us what? The surface area. On number 40, we are given, it's a square-based pyramid, meaning to say that's the sides of a base, they are of what? A square. What we see on the base is what? It's a square. So what is the volume in cubic centimeters? As you can see, guys, cubic centimeters. So convert this to centimeters. 1 meter, 100 centimeters. So multiply by 100, it was going to be 5 centimeters, 5 centimeters. Remember, it's a square. All the sides are what? All the sides are equal on the base. The question needs us to determine what? The volume. Volume is the base area times the height. What you see on the base, it's square-based prism. So the area is of a square. What is the area of a square? Side times side squared. So that's 5 squared. 5 times 5. times the perpendicular height as it goes up to the other section that we see on top, to the other square that we see on top. It is separated by what? 10 centimeters. These are in centimeters, so our volume is going to be in what? Cubic centimeters. 5 times 5, that's 25, times 10, 250 cubic centimeters, as we are given there. That is the best answer, was on what? On C. So just like that, volume, base area. If you are given a prism, you calculate the base area, you multiply to the what? To the height. Base area times height. On number 41, what is the capacity of the tank given these dimensions? So capacity is volume, which you can actually convert to the liters or milliliters. If they just say volume, you can just use the units that are there. But if they mention capacity, write your answers in liters or milliliters. So in this case, their answers in liters. So they are conversions that we understand. 1 cubic centimeter as of our volume is equivalent to 1 milliliter. So let's work with centimeters so that we can have what? Cubic centimeters. All right, millimeters, divide by what? By 10. Remember, 1 centimeter is what? 10 millimeters. So that was going to be 40 centimeters. Divide by 10, 60 centimeters. So our volume, as we consider a rectangular prism, length times breadth times what? Times height. So you're just going to multiply. As it is, guys, those dimensions, the way they're given, 90 centimeters, 40 centimeters, 60 centimeters, that was going to give us a volume of 216,000 cubic centimeters. So this volume, we can convert it to the capacity. 1 cubic centimeter, 1 milliliter. It's 1:1, guys. So if this is 2, this is also 2. If this is 3, this is also 3. So what if it is 216,000? It is also equivalent to 216,000 what? Milliliters, which we do not have here. The answers for capacity are in what? In liters. So let's convert to liters. A liter has got 1,000 milliliters, remember. So divide by 1,000 milliliters. So that was going to give us 216 liters, which is on what? On B, 216 liter capacity. So you can have it in that way. So if you check those basic question papers that we have been used, if they say capacity, you can just calculate your capacity as your volume straightforward. But this one, guys, you have to be very, very specific. You must know what you're doing. All right, on number 42, the height of the dog kennel that you're given is 1,4 meters. Determine the volume of the dog kennel in what? In cubic meters. Cubic meters. So we have to change all the centimeters to meters. So change this one. 90. 1 meter, 100 centimeters. So divide by 100. It's what? 0,9 meters. So this is what we have here, which is the same. Here they're telling us, guys, this one, this one, this one, they're equal. So it's also 0,9 meters here. It's also 0,9 meters here, which if we take here from this point to this point, it is the same as what we see on the base. So it is also what? 0,9 meters. So it forms that this is a square that we see here. Okay, anyways, no problem. That's the same here to this height. If we check this height, guys, this height is the same as this height. So it is also 0,9 meters. Here they gave us these two lines now, meaning to say all that we see there is the same. This is 1,2, so this is also 1,2 meters. This is also 1,2 meters. And here they're telling us these two, they are equal. So meaning to say we are having an isosceles triangle on the top. So meaning to say a perpendicular height can be drawn at 90 degrees, subdividing that triangle into two equal parts. Okay, that's the understanding that we have. All right, no problem. The question needs us to calculate the volume. So the volume here are of two things. There are two things to be considered. There is the one that is below here, which is a rectangular prism that we are seeing. That's a rectangular prism. So we have to consider this one below our rectangular prism, this one in the form of what? In the form of a rectangle to the top. Then above, it's a triangular. Now, as you can see, it's this cross section is a triangle. So there are two things to be considered: a triangular prism and a rectangular prism. That will be our total volume of the whole dog kennel that we are given there. So these formulas, they are easy. Volume is simply base area times what? Times the height. Base area. What you see on the base times what is on the height. So if we are to consider that part, we can see that the one that is below the rectangular prism, we have got a square base. It's a square base separated to this other side. It is because there's another section there that you'll be seeing. Guys, okay, no problem. Let me put it this way. Maybe you might understand me. What you see here, this thing here, this square, is the same thing that you'll be seeing on the other side. It will be showing there as a square again. So that's your base area. That's the one that you refer to as your base area. So it is a square. Then the height from that square to another square that you'll be looking onto the other side, this will be your height. So meaning to say the first part, it was going to be base area, area of a square. Remember, area of a square, guys, is what? Side squared. Side times side, 0,9 times 0,9. That's the area of a square. This one, a square, side times side, base area, times the height from where it is, this square, to another square that we're supposed to see on the other side, which is not shown. There's a difference of what? 1,2 meters in between. So this is our first volume from the rectangular what? Prism. You can just say it will be a square based now, because what you see there on the base is what? It's a square. Okay? But if we look properly, we can see that there is also on top a rectangle. I mean, this one is now a triangular, because what we see on this side, it's a triangle, which is the same thing that will be looking on the other side. There will be a triangle here that will be showing it. There will be another triangle there. It's only that they did not show it. So for us to determine the base, I mean the volume from our base area, we are saying it is base area half base times perpendicular height of a triangle times the height. The height that we talk about is the distance from one shape to another, from this triangle to this triangle, which is what? The 1,2. That is the height now from one shape to another, which is that 1,2. So you can just call it capital letter H. All right, or let me just write 1,2 so that we know which height are we talking about. So on the triangle now, we have the base here, from here to here. This is our base. This is our triangle, 0,9. But we do not have its perpendicular height, this one. Its perpendicular height. This is the edge of the perpendicular height of a triangle from here to the top. So where are we going to find it? Remember, they told us that the whole of this line is what? 1,4. So out of that, there is 0,9, which is equal here. So you must get rid of the 0,9. We have what is remaining on top, which is the same as this one. So it's 1,4 minus 0,9. So the height of the triangle, this one, the perpendicular height, is going to be 1,4 minus 0,9. Okay, that was going to give us 0,5. So it is what? 0,5 here. That's our perpendicular height of the triangle. So we can have the volume. As I said, volume is what? The base area times the perpendicular height, which is the perpendicular, which is the height from one section to another, which we already have 1,2, this one. So let's substitute half of what? The base of the triangle, 0,9. Its perpendicular height of the triangle, 0,5 meters that we had there, times the height now, which is the length from one shape to another, from this triangle to this one, our 1,2 there. We are done. We are done. So as we can see, this sums up to the total volume of everything that we see there. The rectangular and that triangular prism separated. So that was it, guys. Use your calculator. The first one was going to give us 0,972. This one was going to give us 0,27. Combined together, that's 1,242. Remember, we are using meters, so our volume is in what? Cubic meters. So that's 1,242, which is on what? Which is on B. So that was it on question 42. The answer was going to be on what? On B. You just have to analyze your diagram. Analyze that. 43. What is the surface area of this half cylinder? It's a half cylinder. Remember, there's a question that that was saying what is the surface area of a cylinder, which actually gave us that formula 2 pi r squared plus 2 pi r h. If you still remember, there was a question which we used. But this one is a half cylinder. There is a half circle. There is a half circle there. Half circle. Half of it. So meaning to say, these will be affected. The circle will be affected. Even these 2 pi will be affected. There are two circles, which is actually divided into two. It's a half. It's a half circle, a half circle. So that alone affects our area when it is a half cylinder. So when you have to calculate, guys, you adjust your formulas. So instead of us using 2 pi r squared, we are simply going to use what? Pi r squared. Divide that one by 2. The 2 pi r h divided by 2 is going to be pi r h. Then if you notice, there is a section here which is remaining on top, which is not curved, because this one is for the curved part. There's this one which is not curved. It's a rectangle that is formed on top. You must add a rectangle which is formed. Length times breadth. It's another area. That's complete everything that we see. Guys, surface area, it's everything that you see. Everything that you see. So this one is adjusted from a complete cylinder, then a rectangle formed on top. So with this, we can find our area. Pi r squared, do we have the radius? Pi, our radius from the center to this, that's our radius. Okay, the answers also, let's check. Our answers are in square meters. So there's a need for us to convert our radius, 25 centimeters to meters, divide by 100, that's 0,25 meters, all right? So we have our radius, 0,25 squared, plus pi times the radius, 0,25 times the height of one section to the other, which is what? The 2,4 meters. Plus length times breadth, all as of the rectangle. That is going to be 2,4. All right, so this one is going to be 2,4. This is our length. And the breadth, which is this one, as we can see, the breadth, guys, it will be the diameter here. So it will be the diameter, the whole of this one. Remember, diameter is 2r there. We have got the radius. Our radius is this one. So multiply by 2 to get what? To get the diameter. 0,25. It was going to be 0,5 meters. So this is our diameter. The diameter is our breadth. This is our width or the breadth. Okay. So that's 0.5 meters, the diameter. So be very careful on that one. Okay. So this sums up to everything, guys, that we need as our surface area. So these are the typical questions that you'll be facing, guys. You just need to be very careful. And our answers rounded off to 2 decimal places, as you can see. So make sure that you round off to 2 decimal places on your calculator. That was going to be 3.28. Okay. It was going to be 3.28 square meters to 2 decimal places, which is 3.28 is on what? Is on A. So the best answer was going to be what? Was going to be A. So you must also consider how the answers are rounded off and how are they given. They are given all in square meters. So use meters on your calculations. That's the most important part. On number 44, the height of the water tank is 177, the diameter 180 centimeters. After heavy rains, the water lies at 450 liters mark of the tank. What percentage of the tank will be filled with water? So it's from capacity. Remember that question that was asking us about capacity. So when there is these heavy rains, this is the level of water that has been covered. Maybe it is up here, or maybe it's here, maybe we do not know. So let us find the capacity of the tank, the whole tank as it is. What is its capacity? So considering the tank, okay, we have the diameter. So let's change this one. Let's have our radius diameter over 2. 180 divided by 2, that's 90 centimeters. So the radius here is what? 90 centimeters. So we can have what? Our volume. Remember the volume, guys, of a cylinder. Base area, pi r squared times the height. So that's pi times our radius, 90 squared times the height, 197 here. So this was going to give us the volume. That's our volume. I'm just going to leave it in terms of pi, or you can even have it as a decimal, but make sure that you store your values on your calculator, guys, all right? So it was going to give us something like 501.303.9,397, something like that, in cubic centimeters. So the capacity, remember the relationship I mentioned before, guys. 1 cubic centimeter to what? To 1 milliliter. So this is exactly the same as in milliliters, as it is. It is the same value as it is here in what? In milliliters. Why talk about the milliliters? Because it's easier for us to convert them to liters, because each liter is equivalent to 1000 milliliters. So we can simply divide by what? By 1000 to get the liters. So our tank has a capacity. When it is a full tank, its capacity by dividing by 1000 in what? In liters, it was going to give us 5,000 and 13 comma 03 039 and so on and so on, 97 and so on and so on, in liters. This is the capacity of the tank, full tank, as it is. But here they're saying after some heavy rains, the water lies what? 450 liters mark. Meaning to say it's not full. Because our tank, guys, it's we have a tank of 5,000 and something liters. Only 450 is filled. So as a percentage, to find the percentage of the tank which is filled with water, this is what our tank can carry. So the water that is there is what? 450 liters over what our tank can carry. Our tank can carry what? 5013,039, whatever that we have there, liters. You multiply to 100%. So these are liters, they cancel, guys. So this is it times 100%. So it was gonna approximate to two decimal places, as we have got our answers to two decimal places. It was gonna be 8,98%. This is the percentage of water in the tank. The water in the tank. So the best answer is what? Is B. So that was it on our question number 44. So guys, you see, they can ask such questions. They want you to be very careful in terms of the units. The units. All right. On number 45, we have got a cardboard container can hold 300 milliliters of chocolate milkshake. What is the height of the container as shown above? This one. All right, so it's a triangular one that we are given, and they want this one. They are centimeters, they are millimeters. So guys, here we can choose any unit, centimeters and centimeter or meters. I mean, centimeters or millimeters, we can convert anyone to another. So they want the height, guys. They gave us what it can hold, the capacity. So capacity can be equated to the volume, guys. Remember, a cubic centimeter to 1 milliliter. So this is equivalent. If it is 1:1, so 300 milliliters is equal to what? 300 also cubic centimeters. So we have a volume of 300 cubic centimeters. We need to calculate the height. So you just ask yourself how uh how to calculate the volume in the first place. If I'm given a shape like this, the volume is always the base area, what you see on the base times the height. So this is the same triangle. So what we see on the base is a triangle. It's a triangle. So its area is supposed to be half base times perpendicular height. So this is our base area times the height. We have volume now. We have volume. But if we consider that now, we'll see that we do not have the height of the triangle also. Here, this one. The height of the triangle, we do not have it. So we must use the properties or the information that we are given to find that height because it's not there. We have got the given side, the 80 millimeters, which is our base, and also the square root of this one, which is, those are the only ones that we are given. So can we determine the perpendicular height of our triangle? This one. What can we use? Yes, we can figure out our Pythagoras theorem, as we do understand that's an isosceles triangle there. So it simply tells us that this line will be subdivided into two equal parts from the perpendicular height. The perpendicular height bisects it into two equal parts. So divide by 2, that's going to be 40 millimeters, 40 millimeters on the other hand. So using one of the triangles, we can calculate our height, as we have got two sides. We can use our Pythagoras theorem to calculate what? To calculate the third side, as it states, hypotenuse squared is equal to a squared plus b squared. Our hypotenuse, okay, the one facing 90 degrees. So we must square that one. Square root of 4100 squared is equal to a squared plus b squared. Those are the shorter sides. So we've got 40 squared plus h squared. So that's it, guys. Square root, then you square it. It is simply removing the square root. So that's 40 squared, which was going to be 1,600, and that's plus h squared. Take this one to the other side. It was going to be a minus, and that was going to give us 2,500 equal to h squared. Introduce the square root. That's 50 here. So it's going to be 50 millimeters, which is the height of our triangle, not the height of this, to say from the base to another base. No, the height of the triangle. To find this height of the shape which is separating the two triangles, we must consider the volume. That's where our volume now plays a role, the volume concept. Volume here, it's what? Base area, which is half of, okay, the units, guys, as the volume is in cubic centimeters, convert these to centimeters now. So the base of the triangle is the 80 millimeters. So convert to centimeters, divide by 10, it's what? 8 centimeters. Our perpendicular height, which we calculated 50 millimeters, divide by 10, that's what? 5 centimeters. Okay, so we have got 5 centimeters on that one. Okay, let's hope it's not going to affect me here. 5 centimeters. Okay, so guys, like I was saying, base area of a triangle, half base, half of 8 times the perpendicular height, 5, same units. So this is our base area times the height to the other section, the one that is separating, which is this h. We must get the volume that we are given of 300 cubic centimeters. That's it. Base area times perpendicular height, just like that. You have your volume. So that's it. Half of this one, half of 8 is 4. 4 times 5, that's what? That's 20. So 20 times h, that's 20h, which is equal to 300 divided by 20 by 20. So h is what? That's going to be 15. So that's 15. We're using centimeters, cubic centimeters. So these are in what? Centimeters. 15 centimeters, we do not have that. So what happened? They are millimeters. So remember, 1 centimeter is what? 10 millimeters. So if we multiply by 10, it's what? 150 millimeters. Exactly what we have on what? On B. So you must also check the proper answers at the end. Okay, so that is, you play around. You play around, as you can see. It was a play around type of a question. Interesting questions indeed for someone who wants to learn. So this was the first section that we are given, which is our section A. Then we're going to consider our section B. Okay, so that was it. 45 marks here. Let's consider section B. Question number 46, where we are given a diagram, and on that they said, translate the polygon here, 5 units to the left and 1 unit up. So it's 5 units to the, you move 5 to the left, going to the left, then you go up after that. So you can even do it by just moving 1, 2, 3, 4, 5 according to the scale. These are 5 units to the what? To the left. And 1 unit up, we go up 1 unit, only 1. So we end up at what? At minus 2, 0. So we end up here at minus 2, 0. That is our end point. That's where we're going to find the image of A. Let's move on to B. 5 units to the left. 1, 2, 3, 4, 5. Then 1 unit up, it will end up here. 1 unit up. So it will end up at what? Minus 3, minus 1. We mark our point. That's our B. Okay, the image of B. C, 5 units to the left. 1, 2, 3, 4, 5. 1 unit up. It goes 1 unit up, so it's going to end up here at minus 3, minus 3. We mark our point, so that's our C bar. We move on to D. 5 units to the left. 1, 2, 3, 4, 5. According to the scale. Then 1 unit up. You move 1 unit up according to your scale. So it was going to end up here at minus 1, minus 3. That's our image of D. The image of E, 5 units to the left. 1, 2, 3, 4, 5. Then 1 unit going up. It will end up at what? Minus 1, minus 1 here. So that is the shape that we're going to end up with at the end, just like that. Or you can use the condition that I was explaining before to say 5 units to the left, you subtract each point. So if it is x, it's a 3, like this one, it's a 3 versus minus 1 for an example. 3 versus minus 1. 5 units to the left, it means we're going to subtract 5. Then 1 unit up, we add to the y value. So 3 minus 5 is what? 3 minus 5, it's minus 2. Minus 1 plus 1 is what? It's 0. So the image will end up at minus 2, 0, which is this one. You mark your point. You do the same thing for B. You do the same thing for all these points. You will be subtracting 5 on x. You add 1 on y. Subtract 5 on x. Add 1 on y. Each and every point, it was going to end up like this at the end. You're going to have something like that. All right, so that was our transformation. That was question number 46. Then if we are to consider another part, which is now question 47, we have got straight lines, A to D, then B to E, it's a straight line. C to F is also a straight line which intersect at O. So there we can see vertically opposite angles, guys, are formed. All right. The angle, this one B, let us just name them in this order, 1, 2, 3, 4, like that. So I'm just going to say this is O1, this is O2, O3, O4, 5, and 6. So from our vertically opposite angles, we can see that angle O2 and O5. Those ones are vertical opposite angles. They will be the same. So O5 is also X, vertically opposite angles. Angle O2 is equal to angle O5, which is X. Vertically opposite angles, guys. Vertically opposite angles, okay? It is the same thing as angle O1 and O4. Same thing, angle O1 and angle O4. That's equal to X. Again, vertically opposite angles. Then O3 and what? O5. Angle O3 and O5. They're also vertical opposite angles, guys, which is what? 3x. This is 3x, so this is also 3x. We are just understanding what we are given from the information. But the question is, what is the size of what? Of x. So to find x, guys, we have got all the angles which are at a point. Remember, angles at a point add up to 360. So I'm going to add everything. Angle O1 plus angle O2 plus angle O3. All these plus O4 plus O5. Okay. 1, 2, 3, up to 5. They must give us 360 degrees angles. Sum of angles at a what? Sum of angles at a point or a complete revolution. So O1, that is x. O2, that is x. O3, that is 3x. O4, that is x. O5, okay, this is 5, there is 6, guys. So I'm supposed to be 6 here. 6, not... So there's another one there. How did I take this one? There's 6, guys. So O5 is x and O6 is what? Is 3x. There are 6 angles. 1, 2, 3, 4, 5, 6. Okay. I didn't see it properly there. So this is equal to 360 degrees. So add all of these ones. 1 plus 1, that is 2 plus 3, which is 5 plus 1, that's 6, 7 plus 3, which is 10. So it was going to give us 10x equal to 360 degrees. All right, so simply divide by what? By 10 by 10. So our x was going to be 36. Okay, this one, that was it. That was it. You just have to consider those properties, guys. Angles at a point. So just correct this one is O3 to O6. The rest they are fine. 1, 2, 3, 4, 5. So O2 and 5. O2 and 5. 5 there. I wonder why I have that same. Okay. But I think this is the corrected part which we can use. All right. Number 48. The area of a triangle is 100 square centimeters. Its base 400 millimeters. What is the perpendicular height? So let's convert same units, guys. Let's change this one to centimeters. Divide by 10. That's 4 centimeters. So it's a triangle that has got a base of 4 centimeters. We do not know its height, but we've got what? We've got its area. So we're done. As we do understand that the area is half base times what? Half base times perpendicular height. We can consider that way. Okay, so area half base times perpendicular height for a triangle. So that's it. Centimeters, which are square centimeters there. So 100 is equal to half of the base, our base, the whole of this line, for the height, the one that meets at 90 degrees, which is the one that we need. So let's find that one. Half of 4, that's 2. So 100 is equal to 2 times h, which is 2h. Divide by 2 by 2, that's our height. We are done. So that's our height is going to be what? 50 in centimeters as we had the others. So we've got our height in centimeters just like that. So questions can be like that. They can be direct. You just need to apply the basics of what you know. On number 49, there are lines that are parallel that we are given and some of the angles. What is the size of T1? Okay, what is the size of T1 for 5 marks? The size of T1, this is where we've got our T1. I think we had a similar question like this on those multiple choice. Yeah, it was just like this one. Anyways, let's see, guys. From the lines that are parallel, we are forming Z, which is alternate angles, angle Q and angle S. Alternate angles, remember they are equal. So angle S is 38 degrees. Angle S is equal to angle Q, 38 degrees. Those are alternate what? Angles. Okay. Angle R there and this R, they are equal, vertically opposite angles. So the angle R1 is equal to 75 degrees. Those are vertically opposite angles. Okay, so that will be 75 degrees. So to find T1, guys, T1 is direct. It's an exterior angle, so it's the sum of the opposite interior angles. 75 plus what? Plus 38. That's exterior angle. Exterior angle equal to what? Sum of two opposite interior angles. So that's it. So our T1 is the exterior angle. So with these guys, you can simply add these two. That was going to give us 113 degrees. Okay, that was it. You just have to consider as it is on number 50. This is a parallelogram, T VUN. So those two sides are parallel and equal. These ones are also parallel and equal. So if this is 4, this is also 4 centimeters. What is the length of O to N from O to N? Okay, what can we do? the length of ON here. Okay, no problem. We can simply use the diagonal concept. Remember, these diagonals for a parallelogram, they do bisect each other. So if this is 5, this is also 5. So guys, TON is what? A right angle triangle. So use what? Use Pythagoras theorem. That is the hypotenuse, which is OT squared, is equal to the sum of the square of these, which is TN squared and the ON that we want, just like that. So that's it. From O to T, we have it. That is 5. So 5 squared TN is what? Is 4. And ON is the one that we want. So we have formed an equation. 25 is equal to 16 plus ON squared. Subtract the 16 here. That was going to be 9 is equal to ON squared. So let us find our ON. Simply introduce what? The square root. So that's 3 centimeters. Okay, that's our ON. So ON is what? 3 centimeters. Okay, just like that. It was a direct question. 51, a company stores boxes in a room with these dimensions. All right, guys, length times breadth times height, it is volume from the LBH. So length 5, the height, length times breadth times height. That was going to give us the volume, which is 30 square cubic volume, cubic units. Okay, that's the volume of what? The room that you're given, like the volume of that to the top. How many boxes can fit in this room? How many? If each is going to be measuring this, each, they're in centimeters, but we calculated this, guys, these were meters, meters here, cubic meters. These are meters. So convert the centimeters to the what? To the meters, so that it will be easier for you to divide. As you can see, how many, for you to find that one, you simply need to get this volume of the room. You divide by what? By the volume of the box, each box. So the volume of each box, all right, is going to be what? In cubic meters. So let's divide to convert these ones to meters. 1 meter, 100 centimeters. So we're going to divide by 100. That's 0.1 meters by 100, 0.06 meters by 100, 0.04 meters. So we have our volume, length times breadth times height. We already wrote it there. So our length, 0.1 meters times 0.06 meters times 0.04 meters. It was going to give us the volume of each box, 0.00024 cubic meters. That's the volume of each box. So how many boxes can be found in this room, which has got a volume of what? 30 cubic meters. So number of boxes now, it is simply going to be the volume of the room where you are to keep those boxes. You are keeping them in a room which has got the volume of what? 30 cubic meters. Divide by the volume of each box. Each, it must be each. 0.00024 cubic meters. Same units, they cancel. So 30 divided by this, it was going to give us 125,000. Okay, this is what we have, boxes. So those are the number of boxes that you're going to have at the end, just like that. It is like that question of a capacity when they say there's a tank, then how many, maybe 5-liter bottles that can be filled from that tank, something like that. Number 52, they gave us this diagram. A grade 9 class wants to determine the height of the school's flag. So the flag here, this is the height, okay, from the ground, okay. They use a laser light source mounted on a structure with 2 meters height from the ground. So the laser here, it has a height of 2 meters. So this is also 2 meters here. This is also 2 meters here. Okay. To shine light over the what? The wooden beam. So it will shine it. The light shines over 20 meters high wooden beam to the top of the flag. So the first one, it is the 20 meters. This one, 20 meters high. So 20 meters high, the whole of it. So guys, if this is 2 meters representing our laser light, therefore we're going to subtract 20 minus 2 so that we have got the height above, which is from the triangle, guys. As we do understand, guys, we'll be dealing with triangles here. There's no way solving triangles. So we want what is inside of the triangle. So we need this one above on top. What is inside of what? What is inside of the triangle? This is the one that we need above. So it's gonna be 20 minus the 2 meters, the one that is this one below. Okay. So let's see if we are to consider 20 minus what? Guys, I'm just going to be in short here. 20 minus 2, which is 18 meters. So above here, there is 18 meters height. All right. Then here, we do not know, but it is the same thing, just like to say, if we had something, we're going to subtract the 2 meters, or if we want the whole height, therefore we're going to add the 2 meters. So that is the concept. So the distance between the flagpole and the wooden beam is 100. The flagpole to the wooden beam, 100 meters. There's a distance which is the same length here, 100 meters. Then this one is what? 10 meters. Okay. So that is what we have there. So the question is, determine the height of the flagpole from what? From the ground, as we are to measure it from the ground. This was just a similarity, guys. Remember, similar figures are equiangular. If we check properly, we can see that these two triangles are similar. This triangle formed here and the bigger triangle, that one, they are similar. The smaller triangle has got, let's just call this one A, B, C, D, E. A is going to be common angle. Then at B, it is 90 degrees. At E, it is 90 degrees. The angle at E is the same as the angle at D that is remaining. So those are similar figures, similar triangles, by just looking onto the diagram without wasting our time. So similar figures, think about what? Ratio of corresponding sides. Also, by just looking into our diagram, guys, we can even look into the corresponding figures in terms of the length. 10 of the smaller triangle corresponds to the bigger one there, the outer. When we talk about this whole triangle, the whole length there. So it's 10 plus what? Plus 100, which is going to be 110. It must be equal to the corresponding, this 18, this one, the height of the wooden, this one in the triangle. It is 18. It corresponds to which one? To this height here of the triangle also, which is of the flagpole, but it is the height above, which is above this one from C to D. So let's just call it H, or we can just call it X. All right, so it's going to be 18 over X. So X is the length CD, not the height of the flagpole. The height of the flagpole, you must add the 2 meters because it's from the ground. So find this x first. You can just cross multiply there. That is 10 times x. 10x is 110 times 18, then divide by 10 by 10. So our x was gonna be 11 times 18, which is 198 meters. So therefore, the height now of the flagpole, including that laser light height of 2 meters that we talked about before. So it gives us the complete height of the flagpole. So therefore, our h for the flagpole is going to be 198 plus 2 meters. These are meters, 2 meters. So adding this, it was going to give us 200 meters. Just like that. So you analyze the question according to the information, the diagram that you're given. You have to analyze your information. So here it was just a play around. They just wanted you to play around with your similar figures, then apply that into consideration. So that was it, guys. The full paper for our GEC. Let us prepare in as much as we can for the exams that are ahead of time. Make sure that you know all the basics from term 1 up to term 4 as you have in your ATP, your annual teaching plan, your syllabus. I have illustrated each for each and every term. So go through each and every section, prepare, understand all the basics so that you'll be able to cater for these exams that are ahead of time. So that is it, guys, from Mason African Motives. Till we meet again.